everyone, welcome back. It's great to have you here today. Today we'll be revising proportion. There are two examples. Please get your pen and paper ready and work through these questions with me. So in this video, we are going to look at two different types of proportion. Direct proportion and inverse proportion. So here is an example. A spring has extension 8 centimeters when a mass of 2 kg is attached to it. Now in part A, we wanted to find the mass that produced 40 centimeters extension. And in part B, we wanted to find the extension when 6 kg of weight is attached to it. So what we are going to do is to set up a table with extension and mass. From the question we know 2 kg mass produce 8 cm extension. Therefore, if we want 40 cm extension, I will multiply 8 by 5. Then that means we needed to multiply 2 kg by 5 to get 10 kg. It's because the heavier the item, the longer the extension, so they are in direct proportion. Similarly, if we want to know what extension will be produced if a 6 kg mass is attached to it. Now to go from 2 kg to 6 kg, I'll have to multiply by 3. So then that means I'll multiply the extension by 3, and that is 24 centimeters. When one variable increases, the other variable also increases. This is called a direct proportion, and we can say E is directly proportional to M. We are using this symbol here. Now let's look at the relationship between the mass and extension. If I multiply mass by 4, I will be able to work out extension from there. So that tells us E is 4 lots of M. So if we were to plot the points, we can see that it will give us a linear relationship. It's going to be a straight line. Now the sketch here isn't accurate because this line needed to go through 0, 0. Okay, so if the question says two variables are directly proportional to each other, then we can say E is directly proportional to M. That means E is K lots of M. And EM have a linear relationship. Okay, so now let's move on to talk about inverse proportion. Here is an example. 6 cows can graze a field in 15 days. And in part A, we wanted to work out how many days it would take 2 cows to graze the same field. And in part B, we wanted to work out how many cows do we need if we wanted to graze the same field in 3 days. Now let's think about this problem. If we have less cows, that means it takes longer to graze the same amount of field. On the other hand, if we have more cows, then less time required to graze the same amount of field. So what we can do now as well, we can set up a table. One says number of cows, the other one says number of days. From the question, we know it takes 6 cows to graze a field in 15 days. If I reduce the number of cows from 6 to 2 by dividing by 3, that means I will need to multiply the number of days by 3, and that will give us 45 days. However, if we were to decrease the number of days from 15 to 3 by dividing by 5, then that means we have to increase the number of cows 5 times, and we need 30 cows in this case. So in this case, if one variable increases, the other one decreases, this relationship is called inversely proportional to each other. So we can write C inversely proportional to D, 1 over D. And if we look at the number, what is the relationship between these two numbers here? If I multiply number of days and the number of cows, I will get the same number, 90. Therefore, we can find an equation linking C and D together. C is 90 over D. And if we were going to sketch the graph, we will be able to see that this graph looks like this. It's inversely proportional. Okay, that is it for today. Well done for making through to the end, especially if you have tried the questions. Remember, maths isn't a spectator sport, and we have to keep practicing to be better at it. Happy revising, and I will see you in the next video.